Hello everyone. Let's understand DGIM algorithm, which is Datar Gionis Indik Motwani algorithm. Now, this algorithm is used to count the number of ones in the given stream, and how it is done that we will see. This algorithm is good enough to estimate the number of ones with the approximate the probability of 50%. So it gives the estimation of number of ones with an error of no more than 50%. Now, what exactly is DGIM algorithm that we will see? Now, before moving to DGIM algorithm, we need to understand a concept of sliding window. Now, what do you mean by sliding window? So, sliding window is used to count the ones in the windows, which is nothing but a window that in which we have grouped the tuples together. Okay. And this window is a sliding window. So it is basically sliding across the data stream with a specified interval. So this sliding window is also called as a time-based sliding window, and it is having a particular length. So let's say in a given example, let's say the sliding window is of length 10 seconds. That means any tuples or any event that happens within the 10 seconds can be captured by an event. So here, for example, this is the previous window, which is of 10 seconds. So you can see from event 1 to event 6 is captured within this window, particular window. Now, because it's a sliding window, that means it has an interval of sliding through the data stream. So let's say the interval of sliding is of 5 seconds. That means every after 5 seconds, it has to slide over the next tuple values. So here after the 5 seconds, if you see, it slides over to capture the new events, right? Because the events are generating from this side. So events are generating from this side. So whenever new events generates, this window has to skip or discard the old events and capture the new events in the length of 10 seconds, right? So whatever comes within the length of 10 seconds has to be captured by the sliding window. So now if you see E1, E2 has been discarded because that has gone out of the sliding window, and the new events have come, which is E7, E8 and E9. Okay, again after 5 seconds, if you see again after 5 seconds, this window will get it will slide to capture the next new events. So every after 5 seconds, it captures the event that comes within the 10 seconds window. Okay, here the sliding window is containing overlapping data. So you can clearly see E3, E4, E5, E6 was considered in the earlier window, and if I perform analysis, they contribute in the analysis of W1. Later on, these events are also contributing to the analysis of W2 window also. So it is okay where the data is overlapped in the sliding windows, right? Where the data is belonging to more than one value, more than one window. Now, this is the concept of sliding window. Now, how we're going to use the concept of sliding window to count the counting ones problem. So here, the Datar-Gionis Indik-Motwani algorithm, which is the DGI algorithm, it makes use of certain characteristics for the for counting number of ones. First thing that you have to understand is whatever data is we are going to record in the sliding window, the data is coming from the right side. That means that is the most recent data that we have seen, and the data that goes from the left side, it is the data that we've already seen, so which can be discarded. So like in earlier one, right? So data is coming from the right side, which is the most recent data that we have seen, and the data is discarded or we've already seen from the left side. So this is the data that we have already seen. Second, whenever you're talking about the arrival time is incrementing by 1 at each arrival. So as the data starts coming from the right side, the arrival time starts incrementing. There is a timestamp in a bucket. We note down a timestamp in a bucket, which corresponds to the position of the active data element in the current window. And the most recent will always be at position 1. And here, this algorithm uses O, big O of log to n to represent window of n bits. So to make you understand this, this is the image that will help you to understand the concept of sliding window. So given these are the data streams that are coming from the right? And this is the arrival time. That means if you see right now, total, if you consider it as seconds, I'll say that, okay, for the last 46 seconds, these are the record that we captured, right? And if you're considering this as the number of bits that we want to process or a timestamp or a bucket, here if you see the most recent data, will be at position 1 and the most oldest data, the timestamp will be the oldest one. So here I can say that 7 minutes earlier, 7 seconds earlier, I saw this data. And this is the recent data, most recent data that I have seen. So this may be the window that I am looking for. And in this window, I can see that this is the most recent data and this is most latest, oldest data. So the timestamp is incrementing accordingly. Now, here we need to create for such windows. We need to create such windows because this is a continuously flowing data. So we need to create such windows. And from these windows, we're going to estimate the number of ones. For example, in this window, the number of ones are 3, right? But how do we estimate that? So for that, we need to understand the concept of buckets. Now here, we divide the windows into buckets. Buckets are consisting of the timestamps. So we have certain timestamps in the buckets. Timestamps of its right most recent is always 1. So whenever you are considering a timestamp, the most recent timestamp will always be 1. Also, the number of ones in the buckets, whatever buckets you're going to form, the number of ones in that bucket should always be power of 2, right? That means it should be power of 2, that is 2 to the power 0, 2 to the power 1, 2 to the power 2, likewise. So whatever number of buckets, number of ones you're going to form in a bucket, they should always be power of 2. And we refer to the number of ones as the size of bucket. And whatever number of ones you are capturing in that bucket, they will be considered as the size of that bucket. Okay. Now, a few more examples that you need to remember, a few more characteristics you need to remember. First, pay attention to this diagram. Now, this is, let's say, the window that we have captured. So if you see N, this is the entire N, and this is the window that we have captured. And in this window, I need to find out the buckets. So according to the buckets, as we said, that we have to find the timestamp of its rightmost element should be 1. That means whenever you're creating a bucket, the rightmost element of any bucket have the rightmost element as 1. That means your bucket will always start with rightmost element as 1. This is my rightmost element. This is my leftmost element. So rightmost will always be 1. So these are the buckets that we formed. How we have formed, I will tell you later. But right now, if let's say these are the buckets, every bucket, if you see the rightmost element of the bucket is always 1. So your bucket has to start from this one, right? And then anything can go in the left side. First thing, so either 1 or 2 buckets with the same power of 2 number of ones. Next rule is you can have minimum 1, max 2 buckets of the same size. For example, 2 to the power 0, 2 to the power 0 means 1, right? So you may have a single bucket of size 1 or 2 buckets of size 1. So I can have minimum 1, max 2 buckets of size 1. Next, once I have, let's say I have 2 buckets, next value will be 2 to the power 1, which is 2. That means I can have a single bucket of 2 size or 2 buckets of 2 size. So it's 1 or 2, minimum 1, max 2 buckets of the same power of 2 of ones. Next, buckets do not overlap in timestamp. So if you're creating this bucket, for example, you can't have another bucket that starts from here, which will be wrong. So you can't overlap the timestamp, right? You can't overlap the timestamp. The elements may be overlap later on when you slide the window. So they may come later on in a different bucket. But right now, if one element is already in one bucket, that element cannot be considered for another bucket. These are few rules that we have to remember. Okay. And buckets are sorted by size. That means always you have to start from the minimum bucket and then you have to increment the size of the buckets. So this order has to be maintained. You can see it's a descending order. You can't have random orders in your window. Now let's take one example. Now this is an input stream given and here the window size is 24. That means whatever number of elements I got, I can hold at a time 24 bits in that window. So here if you see, these are exactly 24 bits that I got. Now I need to find out the number of ones in this given window. Now how do I do that? Okay, so I need to create buckets for this particular window. Now we know the rule that bucket can start from minimum 2 to the power 0 and then it can go onwards for 2 to the power 1, 2 to the power 2. Next rule is minimum one window of that size. That means you can't have 0 windows. You can have at least one window of that size and then max 2 windows of that size. Now, sorry, 2 buckets of that size. Now here there is a little trick which you have to apply while solving such problems. So in DGIM algorithm, when a given string is, the stream is given and there are number of ones that you need to count, you have to do some reverse engineering here. Count the number of ones in the stream. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I know that the value is 13. That means here I'm going to get 13 distinct elements. So you need to understand how you're going to calculate the number of buckets for this particular problem. So to find out all the possible combinations of 1, 2, 4, 8. Why 1 to 4, 8? Because we know 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8. So I need to find these combinations. And I need to add up to these combinations in such a way that I get 13 as an answer. Right? So let's say, for example, I add 1 plus 1 plus 2 plus 2. Now, why I'm getting it two number of times? Because I know max I can take any bucket two times. So I'm saying 1 plus 1 plus 2 plus 2 plus. Then I can have 4 two times. Let's try to add up these values. So 1 plus 1, 2, 2 plus 2, 4, 4 plus 2, 6, 6 plus 4, 10, 10 plus 4 is 14. So here you see one extra value is coming. So I need to discard something because if I'm adding this, I'm getting 14, but I need 13. So what I can do is I can skip one value. So here if I discard this, that means if I repeat a bucket of size 1 only once and then 2 times 2 buckets, 2 size buckets and 4 buckets, 2 buckets of 4 size. So now you add this 1 plus 2, 3, 3 plus 2, 5, 5 plus 4, 9, 9 plus 4, 13. So I'm getting exactly 13 bits. So you have to do some reverse engineering while solving this particular problem. So there is a little trick that you have to apply. So again, I'm repeating, for 13 bits, you need to find the combinations of values. So I'm getting 1, then 2 times 2 and 2 times 4, because if you add up these values, you will be getting 13 as an answer. That means now from this, you have to start generating those buckets. So again, from right to left. Now from right, because I'm getting 0, you can simply discard the 0 because we are not forming the bucket starting from 0. So you have to look for the first one. Now here I got the first one and we know that my first bucket is of single one. So I can straight away put this as a single bucket. So you can see this becomes my first bucket. Okay. Right, this is my first bucket. After that, now from again I'm getting 1. If I could have got 0 here, I will simply skip them because I'm not searching for 0, I'm searching for 1. So next one I got immediately. Now from this one, I can create another two. This one is already done. Now I'm searching for a bucket of size 2. So this is already 1, then 0, you don't have to consider, and 1. So you see this particular uh, combination gives me a bucket of size 2, right? Because here 2 ones are there. So it's a bucket of size 2. Again, I can repeat the same for next value. Because I'm getting 0, I'm simply going to discard them because it will not come in any bucket. I'll look for the next one. Here I got the 1. So again, I'll just put it into a bucket. Now your bucket can be simply this, and you can simply skip 0, or your bucket can be like this because there is no condition of the right value. So you can put that 0 in that bucket. So this is my bucket of 2 ones. Now after 2, I need to search a bucket of 4 size. So here immediately I get 1. So from 1 I'll start counting. So 1, 2, 3, then 0. I don't have to consider this one. So this is another bucket that I got. So if you see, this is another bucket I got which has 4 ones. After that, I got 0. I am not going to do anything with the zeros because I'm not considering zeros. So I'm looking for 1. Now from here 1, if you see, these are the total 4 ones I got. This is my last bucket. So this is how you're going to create buckets in the given window. So window is of 24 bits. So these 24 bits have been divided into these number of buckets. A very simple technique where you're just finding out the buckets. The rule is every bucket can be repeated only two number of times, minimum one number of times, and the order should be ascending. So this is 1, then 2, 2, 4, and 4. Okay. Now next question is, let's say now let's say we want to update the buckets. Now how the updates of the buckets happens? Let's say a new bit comes from the right side. So in that case, we have to drop the last part of the bucket, which is the left side. Okay. Because if its end time is prior to the end time units before the current time, then we drop the last part of the bucket. For example, here, let's say n is 24, but if we add one more bit to the right side, n will become 25. Now, what we do with that extra bit, right? So the bit stream is always added to the right side of the previous data, and therefore the left side will be discarded. So here, if we add one to the left side, we can clearly see that this one can be taken out, because if we say that our window is of 24 bit, so at a time only 24 bits can reside in the window. That means we have slided the window to capture the new extra bit. Now, because this one comes into picture, because to add one, the one is going outward, that means the buckets will not get changed that much, because again, there are 13 ones only, and therefore the bucket size will remain the same. Okay. Now, sometimes what happens is that there are multiple input stream that is coming that needs to be added to the given stream. Now, in such case, you have to drop so many bits from the left side. Okay, so if these bits are coming and we need to add it to this already available bit data stream, then we don't need to drop too many bits. What we can do is we can increase the size of n. So here, let's increase the size of window from 24 to 32 now. So instead of showing it as a 24 bit now, because there are many bits which has been added to the stream, we will increase the size of n, which is 32. Now let's add this stream to this particular already available stream. Again, we do the same thing. We need to find out the number of buckets in the stream. And you can clearly see that there are total 18 ones in the uh, window. So we know the combination of 18. So we'll have to find out the combination of 18. Again, you can do the same thing. Each window can be repeated for, let's say, each bucket can be repeated for, let's say, the 2 times. So this was, let's try to add up. So 1 plus 1, 2, 2 plus 2, 4, 4 plus 2, 6, 6 plus 4, 10, 10 plus 4, 10 plus 4, 14. 14 plus 8 is 22, which is too big number. So let's try to, just skip 1, 4. So again, 1 plus 1, 2, 2 plus 2, 4, 4 plus 2, 6, 6 plus 4 is 10, 10 plus 8 is 18, which is right. So we don't need one more 4 size bucket and 8 size bucket. So this can be our final bucket size here. So we can have one bucket of size 1, then 2, then 4, and then we have 8. So this single one is one bucket. Another single one is one bucket. Then we don't need to consider 0. Then we have one more bucket of size 2. Then skip this 0. Then again one bucket of size 2. After that, one bucket of size 4. So you just have to count 4 ones in that. So till here, you get one bucket of 4 size. So this one, right? After that 0 comes, just skip it. And then we have all the one bucket which has 8 total. So 1, 2, 3, 4, 5, 6, 7. So likewise, you will get the final bucket. So this is how you can form the buckets for the given data stream where the input stream is big, and that's why we increase the size of the window from 22 to 24 to 32. Right. So here for a single bucket, it uses big O of log n bits to represent a bucket, and the number of buckets in a given window can be big O of log n, and the total space required is log to the base log raised to power to n. And this is how you can update. So as I mentioned earlier, uh, if the from left, if there is a 0 and you're dropping the 0, there is no change. If there is 1 and you're dropping 1, then also there is a no change. But if there are ones and there is no one that is going out, then you have to update the bucket. So your buckets will get updated gradually. Okay. So few things that you need to remember in data geonic algorithm is how you're going to update the windows when new data is coming from the right side. Okay. Last thing that happens is the querying on the buckets. That means how many estimate of number of ones that you're getting in your window. That is done with the help of this formula, where what we do is we sum up all the size of all the buckets but the last one, so we take the half of the last bucket. So here let's say this bucket is of size 1, this bucket is of size 1, then this is 2, then this is let's say 4, then this is 4, then this is 8, then this is 8, and then this is 16. This should be 16 because after 8 we'll get 16, right? So you add up all except the last one. For last one, you're going to divide it by half. So 36 is the total number of estimated ones in the given stream. So this should be the final answer. What are the number of estimates of number of ones in the data stream, in which you are going to add up all the buckets except the last, which will be added as half to the all values. And therefore, 36 is the total number of ones that we are getting. So this is how we query for the bucket size on the given data stream. So that's it. Thank you so much.